my gosh, I just think we found the answer! Hey guys, what's up? Welcome back to another Math Lessons with Josh. Today, we're going to be looking at a question that has to do with compounded interest. So let's not waste any more time and get right into the question. Oh, there's the question. All we gotta do now is read the question to understand what it is asking of us and what kind of information it gives us to help solve the problem. Let's start from the beginning. A savings bond offers interest at a rate of 4.93% per year, compounded quarterly. Suppose that you buy a bond of $100. Okay, let's look at A. Write an equation for the value of the investment as a function of time in years. B. Determine the value of the investment after 10 years. And C. How long will it take for the bond to double in value? Alright, so let's do A now. So because this is a compounded interest question, we know that there's a formula for this. There is a formula for compounded interest and how to solve it. So let's just write out the formula so we can write the equation for the value of the investment. So this is going to be our compounded interest formula. This is what the formula looks like. A is equal to our final amount. P is going to be our principal amount, or in other words, our initial amount. The amount of money that we had at the start or had to begin with. I is going to be our interest rate per compounding period. And N is the number of compounding periods. Now, let's look back at our question and figure out what kind of information they gave us and what A, P, I, and N are in our equation. A savings bond offers interest at a rate of 4.93% per year, compounded quarterly. Suppose that you buy a bond of $100. So, right off the bat, we can already tell that we start with $100. So that will be our initial amount. So from reading the question, we can tell we have an initial amount of $100. So let's put that in for P. The next bit of information that they tell us is 4.93% per year, compounded quarterly. This gives us the information that we need to solve for I. In order to solve for I, we just need to take the percent given in our question, divided by 100 to turn it into a decimal, then divided by how many times per year it's compounded. So let's write this out. We were given 4.93, then we turned that into a decimal. In order to turn it into a decimal, we divide it by 100, right? So let's just do that. Now if you divide 4.93 by 100, you should get an answer of 0.0493. Now, we take this answer right here and we divide it by how many times we compounded it yearly. In our question it said compounded quarterly. Quarterly means 4 times in a year. So that means we'll be dividing 0.0493 by 4. So let's do that. If you divide this, you should get an answer of 0.012325. Now let's try to find our A and our N. In our question, it doesn't really specify what our final amount is anywhere or how many compounding periods there were. So those are unknown values at the moment. So now that we have all the values that we know, let's plug it into our formula. A is unknown. P is equal to 100, so let's put 100 right there. I is equal to 0.012325, so let's put it in. And our N is unknown, so we leave it as N. And there we go. We finished part A of the question. This is our equation for the value of the investment as a function of time in years. This is our answer for part A of the question. Now let's move on to part B. Part B asks us to determine the value of the investment after 10 years. So you may be wondering, how can we do that? Well, let's just use our equation that we made from part A to solve B. What part of the equation can tell us how many years have passed? This n variable right here can. The reason for that is because if we look back to our question, it says per year compounded quarterly, which means there are 4 compounding periods in 1 year, which means 4 compounding periods is a year. 4 compounding periods is 1 year, which means if we have 8 compounding periods, it will equal to 2 years, because you have 2 groups of 4. Because you have 2 groups of 4, and 4 is equal to 1 year. So this is 1 year and this is another year, so that's 2 years. So in saying that, if we want to know how many compounding periods there are in 10 years, we're gonna need 10 groups of 4. 10 times 4 is equal to 40, which means there are 40 compounding periods in 10 years. Let me help you visualize this. So if it's 1 year, that will equal to 4 compounding periods. 2 years will equal to 8 compounding periods. 3 years will equal to 12 compounding periods. 1 year, 2 year, 3 year. So on our 10th year, if following the pattern, if going up by 4, once we get to our 10th one, we should get to 40. So with that, we know that n is equal to 40. Now let's plug 40 into our equation. Let's put 40 as our n. So now let's evaluate this equation to determine the value of the investment after 10 years. So let's start with this. 1 plus 0.012325 is equal to Now let's figure out what's 1.012325 to the exponent of 40. That should give you an answer of. And now if you're wondering why I didn't round off my answer, is because we don't round off our answer until the very end. Now all we need to do is multiply 100 by 1.63229438, and you should get an answer of. So here, now since this is our final answer after 10 years, we can finally round off. Let's round off to the hundreds place, because that's how money is usually counted. Since the number behind the hundreds place is 5 or higher, which is a 9, we can round this up to 3, the next digit above this, which is going to be 163.23. Now that we have our answer, all we gotta do is put it into a sentence form so we can answer this question properly. So A is equal to 163.23, or also known as $163.23. This is the value of our investment after 10 years. So now let's answer this in a sentence form. The value will grow to $163.23 after 10 years. So that's our answer to question B. Now let's move on to part C. How long will it take for the bond to double in value? What is this question asking? It's asking how long will it take for the $100 to double in value. Let's take $100 and double it. 100 times 2, which is doubling 100, will equal to 200. So we want to know how long it will take for our investment to reach 200. Just like in part B, we can use the equation that we made in part A to solve this question. So let's take it, why don't we? So in this situation, we already know what A will be. Since we want to get to 200, we want to be able to get this final amount. So we know that 200 is equal to A. So let's plug 200 into our A value. So the first thing we want to do is try to solve for n. First, let's divide 100 to take it out from this side and bring it to the other side. Now we can cancel this out. Whenever we do to one side, we need to do to the other side. And now, what we have, 200 divided by 100 is equal to 2. So now that we have that, let's add up what we have in our brackets. 1 plus 0.012325, you should get this answer. So once you get to this point, all you gotta do is do systematic trial to figure out what n is. What we do in systematic trial is inputting numbers into our n value until we get to 2. But the thing is, we should be smart about this. If it took 10 years, which is 40 compounding periods, to get $163, it means that our n for this answer will be more than 40. So let's try a number like 50. Let's see what 50 will yield. So all we gotta do is plug in 50 as our n. Plug that into your calculator to see what you get. I got an answer of 1.84. If you plug that into your calculator, you should get an answer of... That's close to 2, but let's see if we can get any closer. Let's try 56. Yet again, plug 56 as our n, just like we did with 50 here. Plug that into your calculator and you should get... Whoa, that's pretty close. That's almost 2. Let's try 57. You should get an answer of... That's pretty close to 2. So let's take 57 as our number of compounding periods. 57 is our answer. It's approximately 57 compounding periods. Now, in order to get the number in years, all we gotta do is 57 divided by the number of compounding periods per year. Now if we look back to our question, it says per year compounded quarterly, which means it's gonna be divided by 4. So let's do this. 57 divided by 4 is equal to 14.25. In which this case, it means it will take 14.25 years for 100 to double in value. So now that we got our answer, let's put it into a sentence so we can properly finish the question. So let us write our answer in words to properly answer this question. It will take approximately 14.25 years for the bond to double in value. There you have it. That's our answer to C. So now let's go over all our answers just to make sure that we know what we got and we know that we're right. A asks for you to write an equation for the value of the investment as a function of time in years. And for A, this is our answer. For B, it's said to determine the value of the investment after 10 years. And our answer was $163.23 after 10 years. That's how much the investment will grow. For C, how long will it take for the bond to double in value? It will take approximately 14.25 years for the bond to double in value. And that will be it for today. I hope that was informative for you, and I hope that you learned a little bit more how to do problems like this in the future. Problems concerning compounded interest. And I hope that it made it a little bit more simpler. Help you understand a little bit more. I hope you guys enjoyed this video, and I will see you guys next time in the next Math Lessons with Josh.
this was really fun.
We hope you liked it too.
Seems like we've just begun when suddenly we're through. Goodbye, goodbye, good friends, goodbye. 'Cause now it's time to go. But hey, I say, well, that's okay.
'Cause we'll see you very soon, I know.
Very soon, I know. Goodbye, goodbye, good friends, goodbye.
Goodbye.
And tomorrow